Hello everyone, let's start a derivation of proper length. Proper length. Proper length is known as the length in reference frame in which rod is at rest with respect to observer. For example, if you are sitting in a train and in front of you one box is kept, so the length of the box that you are seeing by sitting inside the train is known as proper length. It may happen that the observer who is outside the train may see the length of the same box, small or large, of its own original size of the same box length. Okay, so proper length is the length in reference frame in which rod is at rest with respect to the observer. The frame may be moving, but rod is at rest with respect to observer, as same as the example of train. Now, let us consider two frame of reference, S and S dash, where S dash is moving with velocity v in positive x direction. S dash frame is moving with velocity v in positive x direction. The blue line indicates the reference frame S and the green line indicates the reference frame S dash. So this is reference frame S, coordinates y, z, x, and this one is reference frame S dash, coordinates y dash, z dash and x dash. Now the rod of length L0 is kept in the reference frame S dash. The length of the rod is L0. Now its distance from S dash to the last point of the rod, assume it as x2 dash. Its distance from the S dash till first point of the rod, assume it as x1 dash. Now the rod's distance from reference frame S to the first point of the rod, assume as x1, and from S to the last point of the rod, assume it as x2. I hope this figure is clear to you, because to understand this is the main part of the derivation. Okay, now consider rod AB. This is our rod AB placed along x dash direction, in moving reference frame. In reference frame S dash, a moving reference frame is S dash. Now L is equal to x2 minus x1. From here we would conclude the length of the rod, that is x2 minus x1. Assume it as L. Now L equal to x2 minus x1 is known as apparent length. Okay, we'll indicate apparent length by L, and L0 x2 dash minus x1 dash, it is called proper length. x2 dash minus x1 dash will get the rod's length. This is called proper length. Proper length means actual length. I have told you in trains example also. So this is called proper length. Proper length, what is proper length? The definition is most important. Proper length, known as the length in the reference frame in which rod is at rest with respect to the observer. Okay, apparent length, L is known as apparent length and L0 is known as proper length. Now I am very sorry for this mischief. because I had a small kid in my home and it is his mischief only, so I'm sorry for that, but it's okay. Let's start now. From Lorentz transformation equation, x2 dash, from Lorentz transformation equation derivation, we'll get x2 dash as x2 minus vt under root 1 minus v square by c square. If you have not understand Lorentz transformation equation, then please go back and see my previous video of it. X1 dash is equal to x1 minus vt under root 1 minus v square by c square, so that x2 dash minus x1 dash, x2 dash minus x1 dash, we will get L naught, our proper length. Okay, so x2 dash minus x1 dash, when we'll minus it, we'll get x2 minus x1 under root 1 minus v square by c square. Now x2 minus x1 dash is L naught, x2 minus x1 is L, and divided by under root 1 minus v square by c square from above equation. This is the formula for proper length. Proper length is equal to apparent length upon under root 1 minus v square by c square. Okay, so thank you for this. I hope you understand it well. Bye bye.